This is a question of JEE 1988. In this question, we have a cylinder of mass m. Here is our cylinder of mass m, and the radius of cylinder is given as r. So the radius is r, and it is kept on this plank, and this plank is given a displacement of x equals to a cos omega t, and we have to determine the maximum torque which is acting on this cylinder. So first of all, we will draw the ABD of this cylinder. So forces acting on this cylinder is its weight mg, and the normal reaction n, and the contact force, which is the frictional force. One of the contact force is normal reaction, and another contact force is frictional force. This frictional force is static in nature, so the direction is adjusted according to the uh, description of motion. So I am not showing right now the direction. So let us now see the acceleration of this plank. So acceleration of this plank is a equals to d2x by dt square, and this equals to minus a omega square cos omega t. So this is the acceleration of the plank. Now moving to this cylinder. This cylinder is rolling without slipping on this plank. So the direction of frictional force, because it is in contact with the plank, and plank is having an acceleration of minus a omega square cos omega t. So this point of contact will also have an acceleration same as a. Hence we can say that the frictional force acting on this cylinder is towards left. Now our free body diagram is complete. Now writing the equation of motion from Newton's law, net force equals to mass into acceleration. So force acting on the cylinder in horizontal direction is F, and that equals to m into ACM, where ACM is acceleration of center of mass of this cylinder, that is this one. This is ACM. And the torque which will act, because m and n are passing through the center of the mass, so it will not exert any torque. So torque on this cylinder will be F into R, and that equals to I into alpha. So I is mr square by 2, and alpha we know that we have to calculate. So I'm writing this as F into R equals to mr square by 2 into alpha as equation number 1, suppose, and this is our equation number 2. Now the most important thing here is that since the cylinder is rolling without slipping, so point of contact will have same tangential acceleration as that of the plank. So point of contact will have an acceleration a, and which is same as that of plank, and this will equals to ACM plus alpha into r, because the direction of rotation will be in anti-clockwise direction. So alpha r will be towards left, ACM is also towards left, and a is also obviously it is towards left. So we have the equation a equals to ACM plus alpha into r. Now from equation 1 and 2 we can write that F into R equals to m r square by 2 into alpha equals to m ACM into r. This is from equation 1 and 2. So when we cancel out this r and r will cancel out. So m will also will cancel out. So we are left with uh, alpha into r by 2 equals to ACM. Now this ACM is, suppose this is our equation 3, so ACM is A minus alpha r, so we can write it as A minus alpha r. So when we rearrange and solve it, we get 3 alpha r by 2 equals to A, or we can say that alpha equals to 2 by 3 A by r. This is suppose 4. Now A, we know that A is minus A omega square cos omega t. So to find the maximum torque is our I into alpha, and this equals to mr square by 2. I is mr square by 2, and alpha, we have just found that alpha is 2/3 of A by r. So torque will be maximum when other factors are constant. When A is maximum, and maximum value of A is magnitude is A omega square. So when we substitute this, tau max equals to m by 3 and m r by 3, because these two will cancel out and these r will also cancel out. So we have mr by 3, and A is, the maximum value of A is A into omega square. So tau max is therefore, this is m into r into A omega square by 3. So this is our final answer. Thank you.